ಸರ್ ಬಂತ ನೋಡಿ. Yes, sir. Good morning, students. Welcome to YouTube Live. So today we were starting with the core part of our program, exploring pointers in C, day 1, session 1. So before we proceed with today's session, we just have a poll 1 question, which is based on the previous days things what we covered, that is career guidance tips in programming and review of basics of C. So based on that, we have set some questions. I'll be sharing the link on the screen, and also I'll share the same in the live chat as well as in your WhatsApp group. We'll be giving 2 to 3 minutes of time. We'll accept response up till 2 to 3 minutes from the time I display. So please, there are around 5 questions, multiple choice questions. Answer it, and it will be treated as an attendance for you for generating the certificate. Okay. So now here's the link. Please take up the quiz. Click on type it, or else you can click on the link I'll be sharing within a minute in your WhatsApp group or in the live chat. He's free now. He's free now. Sir. ನಡೀತೈತೆ ನಡೀತೈತೆ. So link, is it visible from my link? ಇಲ್ಲ chats ಅಲ್ಲಿ. I don't know why it is taking out. Sir. It is taking out, sir. It is not accepting. It is not taking the link in the live chat. Are security reasons. It will go off. Yes, you can type it as tiny.cc underscore SDM poll 1. You try to do it, sir. Yes, the link is posted in your YouTube live. From here, I'll be giving 2 minutes of time. Yes, yes. So please respond in your YouTube live chat once you are done with your poll question. You just type it as done or submitted. So let me check if I have got any responses. Yes, I have got 9 responses, 10 responses. Be quick, students. Okay, I'm receiving the acknowledgement from students. Listen. So I have received 25 responses up till now. So I'll be waiting for another minute max. 28 responses. 29. Okay. So in another 10 seconds, I'll be terminating the accepting responses. Please submit whatever the state you are right now. Okay, now it's 35 responses, 37. Okay, good. 38, 40. So I received 41 responses, 42. Yeah, yes, sir. Yes. Now I think your time is up. I stop accepting the responses. Let us discuss with the results that you have answered the question. Okay. So 45, 46. People are still submitting the response, but I'll just freeze it up till 50. So I'll wait for another 10 seconds. Shall we stop, sir? Yes. Yes, I'll stop accepting the response. You cannot submit any more response. Total 49 responses I have received, and your yes, sir. The summary goes like this. I just take the summary. The first question, 40 people have answered it as Motor Industry Software Reliability Association. That's correct answer. That comes around 81%. Who introduced the language C? 85% of you answered it as Dennis Ritchie. That's the right answer. Int main into the bracket wide. What it means? It means indicate no arguments and returns integer type. 61% people have answered. So I said it's an important one. And little endian means 73.5% people have answered it as the least significant byte stored in lower address. That's the right answer. And it's a structure. I think the image might have got displayed for you. Here it is not getting displayed in the summary. Yeah, EMP2 is an array of structure, each consuming around 16 bytes. There are 2 such members in it. So total is 32 bytes. So this is the result of your poll 1. Now we'll start with today's session. So stop sharing my screen. Now I invite Professor Kotresh Murali sir for presenting today's session on pointer basics. Kotresh sir,
Yes,
I'm
sir.
adding to the stream. Am I audible to you?
Yes, sir.
Yeah, sir. Please continue. Over to you.
Okay, sir. Thank you. Uh, Thank you, Shrikant, sir. I think you have done with your yesterday's poll one. Dear students, a very good morning to one and all. So today we'll go with the basics of pointers. The point is one important point. A few of you have studied the basics of pointers even in first year C programming, followed by you have a few of you students have undergone the course called data structures, and there also you have learned a little bit of pointers. As we have floated this particular course to both electronics and electrical department, so I thought of going little bit in depth of basics once again. Maybe for few of you, you may think that it's a repetition, but don't worry. As and when you go with repetitive sessions, your fundamental aspects will going to be a much more stronger. So with this, I'll start with my session one on fundamentals of pointers. I hope you all enjoyed the previous session that was given by Navalgun sir and Shrikant sir. So I hope the same interest will be there for the forthcoming sessions also. Is my screen is visible? Is my screen is visible, Shrikant sir?
Yes,
Yes.
sir. It is visible. Please go ahead, sir. Yes, sir. It is visible. Please go ahead, sir.
Okay, thank you. Uh, Welcome to a short-term online course on exploring pointers in C with a team of Navalgun sir, Vijay Kumar sir, and myself and Professor Shrikant Shirpal. So these are the objectives. Mainly, we will take you to why pointers is required or when to use these pointers, how to use these pointers, understand the basic and importance of memory in with respect to C programming, and at the end of this particular course, you will able to understand or you could able to write a simple C programming where you can able to access the data information from the variable through the pointer variable itself. Till now you have studied to how to access the data variable or data or information through the normal variable, but here we go with pointer variable, and already Shrikant sir has covered how to know the different data type size. Now, in this class, in this tutorial, we'll try to understand the pointer's size and normally how to fetch the address through the pointer variables. Okay. The course or the session goes with these many covering these topics: why pointers are required, declaration of pointer variables, declaration of character, integer, and floating point data types as a pointer variables, and all these topics will be covered with the suitable examples. Probably this is how one we feel that when someone says that programming is easy, right? So at least for me during my engineering days, so I could feel that most of the times very uneasy with respect to programming. And how to improve my programming? It's all about practicing and practicing. My students, it's all the time take one compiler, install it, just go on writing the program, understand. Practice makes man perfect, so that's how we also learned this particular programming. Okay, with this, now why pointers are required? Before answering this particular question, so let me very briefly will go why C is popular, because C is very near and dear to hardware, as Srikanth sir dealt with all these concepts. So when I say that memory, it is mainly to access or to store the data from the memory. So normally in the assembly programming, we have a LDR and STR instructions. Maybe in ARM assembly programming or any other programming you take. What about C? That's what our journey starts with respect to pointers. Now here I am trying to take a one analogy to make you understand with respect to pointers. I hope you enjoy that particular slide. So here is a one slide where the Tom is trying to find her little Tom. Where is my little Tom? This is the question that is going to be asked for the Jerry. You know all these Tom and Jerry stories to all of you. And now Jerry has kidnapped the little Tom, and now Jerry is caught by the mother Tom. Now mother Tom asking the little Jerry, "Where is my little Tom?" Now Jerry gives back the answer by giving this particular number or address, that is 0x528132253. So there is your little Tom, and mother Tom walks around the particular address, and it finally found her little Tom. And now mother Tom is very happy. Now that's what the referencing, and it is called as a pointer. Here the moral of the story is very simple. Jerry is acting as a pointer where it holds the address of the little Tom where it is going to be stored. So little Tom is nothing but a information or data. The address pointed by the Jerry is nothing but a pointer. So what is the pointer? Pointers are used to access the information from the memory. Very simple and straightforward. So now we'll try to understand little more fundamentals of the pointers. Before understanding the pointer and using the pointers, I should able to understand the memory. Very important point. So because for human beings, brain is the memory. For hardware, the memory may be the USB, maybe the RAM, etc., etc., etc. Now, when I write a program, then probably I must need a one particular space here. Say, for example, I'm trying to store. So this is my memory block, I assume. And say, for example, I want to store some data in that. Now, this particular memory block, I need to address or I need to name it. And I usually name that particular memory with some variable, maybe X or maybe any English alphabet I will be using here to just to name that memory block. Now, each and every memory will be having some address. So that's what the entire memory block, how it looks. So memory block to store the content, and that particular content is going to be stored with or named with a variable, and that is what we call it as a name of the memory block, and it must possess some address. So in this case, I am considering 2000 as the address of this memory block, and here it denotes like this. Now, how do we convert that in the form of programming? So that's how the programming model is going to be shown as x, which is of data type integer. So x equal to 10. This is normally how we try to model this entire memory block in the form of programming, right? So these particular fundamentals you should understand whenever I write int x equal to some value or float x or character x. So maybe when I say that float, here it is a floating point value that I am trying to store. When I say that character, it is a character data type or a character value that I am trying to store here. That's a difference. Now let us try to understand. See, here in the entire session, we will be moving with not a traditional method of teaching, where we try to take almost all the slides will be of containing the one programs, and where we try to make you to analyze the program, and then we will be parallelly we'll try to deliver the concept of that particular program as well. Okay, so now here is the one particular program where I want to print the address of a variable. So in this particular program, what is the variable? I of data type integer. Now I want to print the address of this particular variable. What is the next line? So that's very simple. Printf address of I is equal to percentage p. Students, make sure that whenever you are using the, or whenever you want to fetch the address, I will be using the percentage p. It is not percentage d, it is not percentage f, it is not percentage c, anything else. Okay, I am trying to print as the address is unsigned integer. So it is whenever I am going with uh, pointing the address, so I will be using the percentage p. Now if I want to fetch the content of this memory, I simply say that I. Very simple and straightforward, right? So quickly we go with the simulation here, how it observes or how the program looks uh, in the Del C++ and what kind of output we may get here. So now I think you know how to use the Del C. I just go to file and say new and save source file. Then you get a new blank sheet here and type your program. Now I just run this program, compile, check for the errors. Uh, it may take some time, like as my PC is download have with the dual OS, so sometimes it take more time. Okay, now very easily you can identify that what is the first printf statement here. The first printf statement talk about the address of the variable I, and I, the value of I is equal to 4. That is what we have we could able to see here. So 62fe1c, which is nothing but a hexadecimal value. My all the time my address will going to be printed with respect to hexadecimal value. So now I just give you one assignment here. Instead of percentage p, what happens if I use percentage q? That you try to find it out, and let me know in the later stage what is the difference, uh, what is the different difference between percentage u and percentage p. Okay, you try to find the answer for this particular question. Now moving further, so what we dealt with this particular slide. So the main particular thing is I'm trying to fetch the address, and first fetching the address is through percentage p, where p prints the address of the variables, and percentage d will going to give me the content of the variable. Is it not? So now moving further, as you know that if I change this integer to floating point, you know that you need to use the percentage f and percentage c. All those basics have been covered in the last class. Now what is the output of this particular following program? So I just give you a few seconds. You can give your answers through the chat box. I will be watching your chat box, live chat box. So what would be the output? X equal to 5. I am trying to say ampersand x equal to 7. So what could be the value of x now? Quickly you can answer me in the chat box. Yes guys, I am waiting for your answer. No doubt, even if it is wrong, not to worry. Okay, Girish Hegde answers it as 5. Any other answers? Shweta 5, Nitra 5. Okay, any other answers? 5, 5, 5. Okay, okay, fine, fine. 5 is fine. Fantastic. Just observe here. Coming to the slide, just concentrate here. See here, the left hand side of this. make sure that RHS is containing some value. The left hand side is, it is not only variable guys, it is having one operator. That is what? Ampersand. Ampersand operator cannot be on the left hand side because it is an assignment operator. Whenever I say that assignment, I must assign this to something else variable. I cannot write this ampersand on the right hand side, and this particular program is totally wrong. You will going to get an error in this particular program because ampersand x is not a variable. It is assignment operator. Whenever you are trying to use the operator, see ampersand may be the operator, star is the operator, like you have many other operator also. Whenever you have a ampersand operator, you must assign it to some variable that is on the LHS side. So the LHS must be containing some variables, and this variable I'm trying to assign with the operator ampersand. So clearly this gives you the error. The reason is ampersand variable is an operator, not a variable. Ampersand variable means ampersand x, ampersand I, ampersand a, anything. With if at all I write a variable, then this is a simply variable. When I write ampersand, then this becomes an operator. Now, so hence I cannot assign any value to this particular operator. So that's the meaning, and hence be careful. Ampersand x is the way to represent the address of a memory block. That's one more meaning here. So I cannot, once again I cannot write it on the left hand side. This must be always on the RHS side. Okay, I hope you got this particular meaning. Okay, now coming how I can able to write the address. So I want to write the address where I know that ampersand x consists of address of a variable x. Fine. Now I want to assign this to another variable. How do I do it, and what is that declaration is called, and that's what we're going to deal with in the forthcoming session. Now that is declaration of a pointer variable. Coming to the heart of the process. Here int x I have declared x equal to 5. Now I'll try to initialize ampersand x is equal to j. What is the meaning of this? There exists a see here. I'll just show you with an animation. See here, x is equal to 5. What does it mean? X is a variable which contains the integer data type 5 and it have some address 1000. Is it not? Now I am trying to store ampersand x. What is ampersand x? In this case, it is 1000. I am trying to store this in another variable called j. So this is how I am trying to do it. So I am trying to store that I declare this one more j variable. I am trying to store this the address of another variable which is pointing to an data type integer. So what is j is called as? J is not an ordinary variable here. J is called as a pointer variable because the reason is it is not storing the any value as such. Here it is trying to store the address of another variable. Want to be noted, it is trying to store the address of another variable. Hence j is called as a pointer variable. Whenever I declare this, I need to declare in such a way that int star j. What is the meaning of star j? So j is a variable of what? Pointer. See, star is an operator. I just write here, star is an operator which indicates that it is a pointer variable. So star followed by some variable will always, you need to read it as a pointer variable of data type in int. What does it mean? It is trying to store, here J is trying to store the address of another variable which is pointing to a data type of integer. That's what the meaning. Okay. So now, how do I save the address in J? It is very simple. This is what we call it as a initialization of a pointer. What is the meaning of pointer initialization? I am trying to store one of the variable address into the pointer variable. So this is all about the declaration of pointer and initialization of the pointer. And the very important point is a variable j is not an ordinary variable. It is a special type of variable which holds the address of another variable, and hence it is called as a pointer variable pointing to an integer data type int. Okay. Now, what is the meaning of star? Star always stands for value at that address. I'll take this particular statement meaning in the later session. Right now, you just understand that star is an operator which means that it stands for value at that address. Okay. Now I can declare whenever I want to declare. It is one type of declaration. So another type of declaration, I say int, I say star, I can write j here with lot of spaces. So this is also absolutely correct with respect to declaration of pointer variable. You got my point? So that's what int star j or int star j declaration tells the compiler that j is going to be used to store the address of an integer value. Okay. Now here is one more particular point. This and this particular point I'll take it in the next slide. Okay. So in this particular slide, you got to know about how to declare the pointer and pointer variable. Okay. Now we try to see this. Another important concept that what we are trying to understand from this particular slide is we are trying to print the variable using the address using the ampersand operator, and also I need to print the content through the pointer variable. Okay. Now how do you do it? So before writing the printf statements, so let us analyze these particular three important statements. Okay. Here, what is I? So I is nothing but the variable which stores the data type of integer, and it must possess some address. Is it not? So this is the first statement meaning. Okay. Now what about the meaning of this star j? Star j, j is nothing but another variable and it must possess. So it is now the initialization. J is equal to ampersand I. What is the meaning of this? I'm trying to store the address of I in another variable called j, where j is nothing but a pointer variable. So j holds the address of my I. So that's what the meaning of j is equal to ampersand I. And j must possess some address. So this is what the pictorial meaning of these three statements. Am I clear? Now, printf address of I percentage p ampersand I. So what the first and second printf statements print? What the first and second printf statements print? Can anybody through the chat box? Yes. So I just say ampersand I. So what will be the answer? You can consider this as the address for the timing. Quick. What is the first printf statement output? Output of the first printf statement? Yeah. Yes, Ganesh Hegde replies it is 1000 and Shweta Shetty 1000 and 1000. Yeah, perfectly. So ampersand I is nothing but address of I, which is nothing but 1000. What is J? J is nothing but ampersand I, which is nothing but it possesses the address of I itself. So these two statements should give me the same answer. What about the third printf statement? Third printf statement ampersand J. Here it will going to give me 2000. Now, the next very important point, I need to obtain the variable values, the content of variables. The first printf statement, so this is one way I am trying to fetch the content of I. So very simple and straightforward, you know it. So what is the other way? I say that, what about this particular statement? See here, now this is very important. Ampersand I followed by star. Look at this, guys. I always have a thumb rule. What is that? Move from right to left. What is I here? I is nothing but a variable which is of data type integer. What is then followed by I have a ampersand operator. What does it mean? It means that the address of I, that is 1000. Now again, I have followed by star. So if this particular star is not present, then I would say that it's straightforward. It is nothing but 1000. But ampersand that is followed by star. The meaning of star is nothing but value that is going to be present at this particular address. So what is the value? So ampersand I, it move to here. So I see the address, then there exists a, I move once again towards the left hand side from right. So there exists a star. Again, I need to know the content of this. So which is nothing but here the value is 4. So this is how you should analyze the programming. Again, there exists one more printf statement star j. What does it mean? Again, I try to write the same way. What is j here? J is nothing but j is equal to ampersand I. It is already initialized and followed by j, followed by star. So which means that star ampersand I and star j are one of the same, which going to give me the content of I, that is going to be 4. So all the three statements will going to give me the same output, that is 4. Is it not? So we'll quickly go through the simulation result of this, and then we go with the further statements. All these are basics, so you might have already gone through this in your basics of pointers. So now we'll see and whether we're going to get the first two printf statements should give me the same address. The third printf statement should give me the some other address which is with respect to the pointer variable address, and with respect to printing the value I should get all the value as same, right? Okay, you can observe here the first two printf statements. The first two printf statements, that is I and j. I'm trying to print ampersand I and j, which is giving me the same address 6 to fe1c, 6 to fe1c. So it may vary in your computer. So it depends on the machines basically. Okay. And here the third printf statement, it is nothing but a ampersand j, which is nothing but the address of my pointer variable j. And if you look at the variable value of I, all the value, that is I star ampersand I and star j, are going to giving me the same value, that is 4. So what is the meaning here? So that is what in the previous slide you have the statement called star means value at that address. So address is 1000. What is the value at this? It is 5. So similarly, star j, which is nothing but star of ampersand x, which is nothing but value of x are one or the same. This is what we wanted to give the clear information with respect to through this particular slide. In this slide, we got to know how to fetch the address through the ampersand operator and how to fetch the content through the pointer variable. Is it clear? Now, so what is the output of this particular program? What is the output of this particular program? So assume that what's the output of first two printf statements? Okay, let me write this. I have always a habit of writing this in the form of pictorial representation. The first three statements. The first three statements will give you this particular pictorial statement. I is equals to variable 20 and it address. Then ptr is nothing but a pointer variable which holds the address of my variable I and it has some address. Now first and second printf statement will going to give me what? Whenever you say that percentage p, blindly you say that it is the address of what? Address of I, because I'm using ptr, so it should give me 1000 here, and even ampersand I, it should give me 1000 itself. Now what about the third printf statement and followed by this? What is the third printf statement? Fourth and fifth. Will it going to give me any error? What about third printf statement? What about third printf statement? This particular printf statement, followed by fourth printf statement, and followed by fifth printf statement. Third printf statement. Any other answers? Okay, what about last two printf statements? Again, it is also going to give me 20. Okay, I think that you are all trying to say that printf of third printf statement will also give me 20. Fourth printf statement will also give me 20, and this one will also give me 20. This is what I assume your answers to be. Okay, now look at this particular program. Assume that this particular statement is not present. Okay, this particular statement is not present, and star ptr, as you rightly said, so star ptr is nothing but ptr contains some address, that is 1000, and it moved to that particular location and it fetches the content, that is 20. Okay, now I rubbed this, I erased this particular point. Now again it will going to give me 20. Now again it will going to give me 20. So all the answers are this and this, and this printf statement will going to give me 20. What about this? If I inculcate the star ptr, what is the output that will going to get? So what does it mean? Which means that, so I am trying to go through what is star ptr here again. So star ptr, which is nothing but ampersand of I, that I move to this particular address, and then there exists a value of that. So I'm trying to replace the value by 20 with respect to 10. So that is what this particular statement is trying to manipulate my variable I. So earlier it was 20. Now after this statement has been executed, the value of I will be 1000. So what is the moral of the program? So very simple. The moral of the program is, at any point of time you can manipulate the pointer variable. The manipulation of pointer variable is possible. So here I am using star ptr. Star ptr is basically a pointer variable which is of data, which is pointing to an data type integer. So I'm trying to manipulate where earlier it was 20. Now I am trying to write it as 10. It is as good as changing the value of I. Instead of telling I equal to 10, I am making use of pointer variable to initialize or to change the value of I value. Very simple. Okay. So I hope you all got this particular program very clearly. So in this, here I'll show some other manipulation that what we can do with respect to pointer variable quickly. Okay. So let us see. I should get the output as 20, 10 and 10. Okay. Okay. So the address, both the address, PTR and ampersand will be giving me the same addresses here. Then first printf statement is 20. That is before manipulating. After the manipulation of the variable I through the pointer variable star PTR, I am trying to change the content of my I memory block. So now the value became 10. So for the third printf statement here, or this printf statement, I am observing the output. I am observing the output through the pointer variable. I am observing the output through the variable I. Okay, normal variable. Now what happens if I change this by this? Is it a valid statement, guys? Look at the change that I have done in the program. Is it a valid statement? Yes or no? Is it a valid statement? Quick. So your responses will make me to understand myself in what way I can able to convince you in much better way. So I'm just observing your chat messages. Yes. What is the output then? What is the output then? What will be the output of, say, first, second, third, fourth, and fifth printf statement? What will be the output of fourth and fifth printf statements? That's fine. That's good answer. That Rajat Patil and Rakshita. Yes, Girish, Rachita, all are giving 15. That's perfectly correct answer here. So the point is, one has to understand here, you can manipulate any pointer variables, you can add them, you can change the value then and there itself. Fine. Okay. So here on the left hand side, I have a pointer variable. On the right hand side, I have a normal variable. Now I change this once again pointer variable. Is it okay? Is it okay? See here, I replaced a normal variable I with again a pointer variable. Is that okay? Yes? Yeah. So which means that, so pointer variable, it is always possible for me, it is always possible for me to manipulate the pointer variable. I can add some value, I can subtract some of the values. That's what in this particular program we do. Okay. Moving further, now I just have some question here. I just have some small question here. Pointer, prior to using a pointer variable, it should be declared, should be initialized, it should be declared as well as it should be initialized, or none of the above. Which one? Prior to using the pointer variable. See, if I declare this as a star j is a pointer variable. So is it sufficient to declare it, or is it sufficient to declare it, initialize it, or should I go for declaring as well as initializing, or none of the above is correct answers? Nikhil Jain says it is C. Madhuri says it is some A, Rachita, A, Girish, Hegde, A. Now just observe carefully. If at all I want to use this star j in programming, look at this. If at all I want to use the star PTR, is it possible without this statement? Without this statement, is it possible to use this in my programming? No, it is not at all possible, right? So whenever I want to go for, prior to using a pointer variable in your program, it must be declared, it must be initialized. So the correct option is C, not A or not B. I hope you got this particular point. So before, whenever you are trying to use this particular star PTR variable in your programming, it is not sufficient if you declare this, you must initialize it. Okay. Now, which of the following is true with respect to pointer declaration? Int star PTR, and there is a one more variable, simple P. The first option is PTR is a pointer to an integer, P is not. PTR and P both are pointer to an integer. PTR and P both are not pointers to an integer. PTR neither a pointer variable nor an integer. Which option is the correct option with respect to this particular declaration? Which is the correct answer? Rachita Behat say the answer is, she says the answer is A. Any other answers? Yes, yes, very good, fantastic. Thank you very much that you are following this session in a much better way. So PTR is a pointer to an integer, whereas P is not a pointer to an integer. You cannot simply assume that since here I have declared the star, this star cannot be implied to this variable also. This is one of the meaning. Okay. Moving further, we try to have a few more declaration with respect to character, how we try to declare the character, integer and floating point variables here. You all might be knowing these basics and this particular chart where int a is nothing but a is an integer variable, very simple or a normal variable. It doesn't mean that star is an abnormal variable. It means that it is a pointer variable. Okay. So which contains the address of a value which is of data type integer. Okay. What about character C? C is a variable of data type character. When I declare it as star C, it becomes a pointer variable which holds the address of another variable of data type character. Okay. Similarly for float and float star f. So the declaration of float star f does not mean that f is going to contain the floating point value. It actually means f is going to contain the address of a floating point value. What do you mean by this? What could you understood? What you understood by this particular note? I'll just let me go with a simple example here. So I have a two type of declaration here. One is float I, another one is float star PTR. Okay. What is the meaning of this star PTR? Do you mean to say that PTR is a pointer variable? PTR is a pointer variable, okay, which has to store some address, or do you think that since PTR is declared as a floating point, so it represents some floating point value? If it is so, the answer is absolutely wrong. So the meaning of this particular statement float star PTR, which means that, so I have a variable I which is which contains the floating point value. The value may be any floating point value. Let me assume that 3.14, our favorite number, pi number, 3.14, which is nothing but a floating point value, and it has some address, right? And when I declare PTR is equal to ampersand I, when I declare this, what does it mean? It means that PTR is trying to store the address of I, which is 1000 in this case, which is pointing to a data type of float. That is what the meaning. Is it clear? So there is a lot of difference here. You should not misinterpret the float star PTR as PTR contains the floating point value. It never. Make one point. I'll make one point very clear. Whenever there exists a pointer variable, either it is a data type of character, either it is a data type of integer, either it is a data type of floating. The pointer variable will never store any other value apart from an address. It will not store the floating point value. It will not store the character value also. Okay, it must always be a address. And with respect to your machines, address is nothing but hexadecimal value, that what we have already saw. Okay, so I hope this particular point is very much clear to you. So similarly, even if I declare the character star j, uh, j possesses the address of another variable which is pointing to character data type. Here PTR is a pointer variable which stores the address of another variable. That variable will be of data type floating point value. Okay. So here is a small example to make you understand the clear declaration of the character, integer, and different float data types with respect to pointer. So I have integer data type I and star II, character C and star CC. I have declared similarly floating point value. I have tried to initialize some random numbers here where I possess the 10 value. C is the character data type. I declared or initialized with one alphabet, F with 3.14, which is a floating point value. Now, once I have declared this, I must initialize these values. So this is what the pointer initialization has been done. Now, let me analyze what is the output of first, second, and third printf statement. What is II here? What is the value of CC? And what is the value of FF? What does it mean? So when I try to say that II, CC, and FF, it must be the address of I, C, and F variable. Am I right? Okay. This is very simple. You already got to know that. But if at all I want to access the data present in the variable I, C, and F through the pointer variable, how do you write? This is one way, that is printf value of I. The one of the way is by making use of pointer variable, that is I will make use of star II, where star II represents pointer variable pointing to an integer data type. Similarly, star CC and star F. Okay, what is the second method to access the content of the variable? What is the second method to access the value of I, C, and F? And there is also third method. There are three different methods where you can access the variable value of any variable. Can you tell me just through the chat box, what is the second method of accessing the data apart from the pointer variable? Guys, Percentage P Utpala, but will it fetch me the content or address? Star ampersand I. Very fantastic. Next, any other way? Any other way? Okay, the one of the answer that has been I received is star ampersand I is also one method. Any other method? So very simple. The second method is simply I go on writing ICF, straightforward. And also, as you rightly said, I can also say ampersand I star will also give me the value of ICF, that is ampersand C of star. Similarly, ampersand F of star ampersand F will also give me the content of I. So here in this example, make sure that there are three ways to access your data. One is through the pointer variable, second one is through the normal variable, and third one is this is also one of the way where you can fetch the variable address, sorry, data of the variables. Is it clear now? Okay, I don't go with the execution. Probably you know with of this particular program, or else okay. Let me see how. I'll just show you quickly. Okay, here the address of II, you can observe it's an integer data type, C is a character data type, and F is a floating point data type. One point is very clear: whenever you declare the integer ICF, whenever you declare the variable ICF with respect to int, character and floating point, the address cannot be a floating point, or the address cannot be a character data type. The address is always an address which is nothing but a hexadecimal value itself. You cannot presume that the address will going to be a floating point, or the address will going to be a character data type. It is always a hexadecimal value. One point is very clear. The second point is, how do I access the data? In a three different ways. Here I have shown you two different ways. One is through the pointer variable, that is what, through the pointer variable star I, star CC and star FF, and the other one is through the simple variable ICF. And you can also use star ampersand of I, star ampersand of C as such. Okay, now moving further. Okay, now what is the output of this particular program, which is most of the time these types of questions are going to be asked in your placements. So can you guess the output? What is the first printf statement you are going to give me? Ampersand A is equal to 7.999, which is a floating point data type. And again, I am trying to declare the B and C as a floating point pointer variable, which is pointing to a float. Then B equal to ampersand A. What does it mean? I am trying to store the address of A in B. And similarly, the same thing I am trying to initialize to the another pointer variable C. Now printf percentage P percentage P percentage P ampersand A. What is ampersand A? Address of A. What is B? Again the address of A itself, because B is equal to ampersand A. What about C? C is again nothing but a ampersand. C is nothing but B, where B holds the address of A. So again, the first printf gives me the same address for ampersand A, B, and C. Fine. Now it's your turn, guys. You should give me the answer. What will be the content of A? What will be the content of star ampersand A and content of B and C? Quick. Quickly analyze the program. We are running out of the time. Just make it fast. What's the answer? What's the answer for second printf statement? What is the content of A? 7777, 7.99, 7.99, 7.99, 7. Why Srinidhi? Why it is 7? Aishwarya Patil also says 7. Why? Vishnu Desai says the 7.99. Now, those who are telling that 7, why it is 7? Why not 7.77? Why not 7.77? Why it is? Why are you truncating the value 7 to the 7? Percentage D. Absolutely correct. It is. Be careful here. Percentage D is there. Percentage D is there. Percentage D is there. It never print. It never print the floating point value. But even it won't print the 7 also. Your answer is totally wrong. So even it will not print you 7 or it will not print you 7.77. First of all, 7.77 is null and void because I have written it as percentage D, and I'm trying to say that A, ampersand A and B and C. Let us see this output and then we'll understand why it is not happening so. So let us try to write. Let me take this to dev C compiler and let me check. Okay. Let me compile and run the program. We'll see what the answer we're going to get. So here, of course, the address are same 6 to FE0C, 6 to FE0C, 6 to FE0C. Why I am getting this ampersand A, B, and C? Obviously, the answers are same with respect to different variables. Through different variables I can fetch the same address, but what about the data here? A is not 7 or not 7.99 also. It is some random value or a garbage value it is going to giving me. What is the reason for this? What is the reason for this? The reason is, whenever I say that always do not rely on the printf statement to truncate your floating point value to an integer, guys. The reason, so once again, when you say that ampersand of A, which is initialized to B, so it has some address. B will be having some B will be storing some address which is a floating point data type. But here I am trying to say that percentage D and it takes to the some other location. It is not guaranteed that it is going to give me the content of this. That is one point. And again, do not rely on the printf function to truncate this value and to give it as an integer value. So never it will going to do such things here. Okay. Now, what's the output of this particular program here? What's the output of this particular program? Moving further. Okay. Now, look at this. Here, one point you should make clear. I have declared two different data types. One is integer I, another one is character data type. So p is going to be assigned with ampersand I. Okay, now point is very clear. On the left hand side, it is character data type. Okay, on the right hand side it is of integer data type. So this is never going to be possible. So we're going to get an error, or sometimes you're going to get a warning stating that these two, on the left hand side and the right hand side, are not a compatible pointer type, because on the left hand side it is character data type, on the right hand side it is integer data type. So most of the times you will be come up with the compilers may give you the warning, or the compiler may give you the error as such. Now still, if I want to rectify, I want to access the data, I want to access the content by declaring the integer and character. Now, what is the way? Here also, what in the last class Srikanth dealt about with respect to typecasting, here also I can go for typecasting the pointer way, pointer typecasting. So that is, on the left hand side, I take the character pointer, pointer variable pointing to a character data type. So I must make this right hand side to pointing to a character data type itself. So earlier the ampersand I was pointing to the integer data type. Now I typecasted in such a way that star, character star. So it is nothing but now I became integer data, from integer data type to character data type, and now I can able to access this value. Okay, so let me check this program whether it works or not. We'll see. Okay, guys, be careful here. One of the very important concept I would like to tell here. See here. Okay, let me analyze what is the first printf statement. First printf statement is address of I, that is ampersand I. Okay, the next printf statement is with respect to p, which is nothing but through the pointer variable. The address are same here. Okay, now the value of I, what should be the star p? Star p should give me the output. Star p is nothing but 1000. I should get it. I'm not able to get the 1000 here. I'm getting some other random variable, the random value. And what about the last printf statement? Value of I through ampersand and star, that is ampersand I, one of the way where I'm trying to access the content of I, which is nothing but 1000. But even after typecasting, I'm not able to get the correct answer. Okay, let me change this to some value where I equal to 10. Now let us see. Now see this. Through the pointer variable and through the normal way of accessing, I'm getting same answers, no doubt in this. Okay, let me change the value here once again. I say 100. Okay, now let us see what's the output. So even now I'm able to get the same answer. When I declare, now I'll change with little bit higher value. I go with the higher value, 2000. Now just observe here. It is giving me some random value itself. Why it is giving me so? Okay, to explain this concept, I just have a, I'll come back to this soon with analyzing this particular program, that is using size of operator in the C programming. What do you mean by size of? Yesterday Srikanth sir told about this particular program. It mainly give you the size of an integer or a size of a floating point or a size of a character. Now in this particular program, we'll try to understand what is the size of star x. Star x is nothing but a pointer variable pointing to a floating type, floating point data type. Star q is also a floating point. Star q is also a pointer variable pointing to a character data type, right? So size of star p and size of star x both will going to give me the floating point size and character. Star p will going to give me the character value size of the value, and star x will going to give me the size of pointer variable of data type float. Okay. Now, what about the first printf statement here? Size of I, where I is nothing but I is declared as integer data type. So it has to give me 4 bytes with respect to my machine I'm speaking. So based on the machines, again, it is going to change the answers. Now, similarly, size of integer, again, it should give me the 4 itself. Size of A is again a floating point data type. We'll see what the output is going to be given here. How the output is going to be changed. Okay. Okay. Now observe carefully. Size of integer is 4 bytes. Size of, again, through I am accessing, where I is declared as a integer. This is one way, and this is also absolutely correct for fetching the integer data type, for fetching the size of an integer. And now here the size of the character pointer and the size of the float pointer is 1 and it is 4. This is very important, where star x and star p, the data type, it's also 4 bytes. Here it is 1 byte. Similarly, if you go for star j of data type int, it is also going to give me the 4 bytes itself. So what is the physical meaning of this? What is the physical meaning of this? So let me go through the very quickly the physical interpretation of this data type here. Whenever I say that integer, it is not actually a one block that I'm going to see. It is a 4 bytes. So it starts with address 2000 and ends with the address of 2003, because it has to allocate me the 4 bytes. Similarly, whenever I declare int star, it also allocate me the 4 bytes, which means that the pointer variable int star j, if I declare it, at a time it try to fetch me the 4 bytes of data. Similarly, if I declare character star, it is going to give me the 1 byte of data. So in the previous case, I declared character data type. I am trying to fetch the integer value, which is nothing but 4 bytes of value. It is as good as I am trying to give you the 4-liter bottles, which is having a capacity of 4-liter bottles. Int is like a 4 liters bottle. Character is a 1-liter bottle. I am trying to give you the 1-liter bottle to fetch 4 liters of water. Is it possible? No, it never possible. But one more point you must remember: the always pointer is always pointing to the first address location. Okay, and hence whatever the single byte that is going to be stored here, that is going to be fetched. So that is what in the previous case you could able to observe. Here I'm trying to say that I is of integer, it is going to be stored with 4 bytes of data. This 1000 is going to be stored in a 4 byte of fashion. Character pointer can fetch only 1 byte at a time, and hence p is going to fetch me here star p is going to fetch me how many byte of data? 1 byte. Though integer data type is 4 bytes I'm trying to fetch. This is as good as a 4 liter of water I'm trying to fetch through the 1 liter of water bottle, which is never possible. And hence, at the maximum what I can bring through the 1 liter of water bottle, I can fetch only one. I can bring only one liter of water. So that's how it works in this case. Hence, when I give 1,000, or when I give more than a value beyond some 10 or 20 or 100, so I could able to fetch only single byte of data, not a complete 4 byte of data. The reason behind that is this particular pictorial representation. I hope this pictorial representation you helped you to understand the content. Is it okay? So now, the last part of my session, and this is where I'm trying to give you the brief touch to integers, arithmetic, pointer arithmetic. So here, the main to understand the pointer arithmetic, I should always understand the what is the importance of star PTR plus plus and plus plus star PTR. Are they same? Are they same here? So what is, let me take an example and let me explain here. If at all I declare this as I equal to 20 and star, so what happens if I write star PTR plus plus, star PTR plus plus. So whenever you write, try to write this big, so there is always a thumb rule that what you should move, you should always move from right side to left side. So what is the first operator that you come across with? So it is plus plus operator. Which means that I need to go for increment. What do you need to increment? So immediately I got PTR. What is PTR? It is nothing but a address location. So I need to increment the address location by 1, right? So now this incrementing the location, it depends whether I have declared the this I as a integer data type, or character data type, or floating point data type. Am I clear? Because see here, if I declare it as an integer data type, as I rightly mentioned here, when I say that, when I say that star PTR plus plus, star PTR plus plus, star PTR plus plus, so it increments my PTR by how many bytes? It must increment this if it is declared as integer I, and it is also declared it as integer PTR, then it will always pointing to a first address 2000, but the number of bytes that is going to be allocated for star PTR is 4 bytes. When I say increment, the address is going to be incremented by plus 4 bytes. So next address location will be 1004. Am I clear? That is what the star PTR plus plus is all about. Or similarly, when I say that plus plus star PTR, plus plus star PTR, what's the meaning of this? I come across with a PTR first, moving from right to left. I come across with a PTR. What is that PTR? It is some address. Okay, then followed by star. What is that value at that address? That is 20 in this case. Now plus plus, increment the content by 1. That is what the meaning. So this is star PTR plus plus increments the address, plus plus star PTR increments the value at that address. I hope you got these 2 points very clearly. So the answer is they are not same. Star PTR plus plus increment the pointer, not the value being pointed by it. Plus plus star increments the value being pointed by it. So with last example, I'll finish my session here with one good example to explain you how star PTR plus plus and PTR star plus plus works. Okay, now look at this particular program. I declared I equal to 4. In this case, I declare a pointer variable star j. I am assigning, initializing the address of I to j. Printf, see, address before executing star j plus plus. So I need to know the address, right? So as I told you, it gives me, it increments my address. So again, since it is an integer data type, the increment should happen with respect plus 4 bytes. The increment should happen with plus 4 bytes. Let us check. So you can observe here, before executing star j plus plus, it was 1 4, 6 to fe 1 4. After executing, it becomes 1 8. I just show you by changing this two characters, and I also say this is also character. And now I'll just we'll just check it what happens here. Did you observe? So since I declared I and j as a character data type, so obviously, as I told you, the size of character star j is 1 byte. So hence, it is going to be incremented by only single byte. Similarly, you can check for float. Okay. Now let us try. Let us type int. I'll come back with respect to any data types, and now I say it as plus plus star j, and here I need to fetch or value, and here also I am trying to fetch the value of j after executing. I need to change this to percentage d because that is declared as integer data type, and here I should see that whether the value at that value of I is going to be changed or not. So I need to get, in this case, first printf should give first printf statement should give me 4, and second printf should give me 5. Let us check. Yes, absolutely, it is giving me the value of my variable is getting incremented, which is nothing but it moved to that particular address, then it try to give me the answer, increment the value here. So again, one more very important point here, instead of this, I'll change it to character. Okay, now I say hey, what happens here? I need to say that percentage c here, right? Okay, what happens here? It should increment by 1, and next ASCII value it has to print. Okay, I'm sorry, it has to be the character here. Okay, now check. Let us check the answer. Oh, character star j. Okay, colon is missing. Okay, could you observe? So before executing star j plus plus, it was printing a. After incrementing, so the next character, that is b, is going to be printed. So one important point, last change in this particular program. Okay, well, let me initialize this I value to 3.5. Okay, now this should be percentage of, and this should be percentage of. What is the answer? Is it a 3.5 to 3.6 or 4.5? Let us see. Guys, one important point. So whenever you declare floating point, yes, it increment the value No, it is not 3.6. It is increment the value by 1, which means as good as telling 1.0. So 3.5 plus 1.0 will give me 4.5. Is that clear? So similarly you can change it to j minus minus and minus minus j. Okay, so here it should be, read it as plus plus. Do not confuse with my printf statements. It is anyways, it is in the double quote, so it's just a printf statement here. Okay, is that clear? Now I have a small confusion. What happens if I don't declare j and star j plus plus? Okay, and what answer it will going to give me? I'm removing star and I'm trying to see whether it will going to give me the incremental, whether it is going to increment the address or not. See here, 1418. So what did you observe? What is the conclusion? Star PTR plus plus is same as PTR plus plus. That's what the conclusion. That's what the conclusion that we drawn from this example. Is that clear? I hope it is running out of my time, so I don't take much time here. We'll finish. Just assignment questions here. Just try to observe what is the size of int star. I declared int star j in your program, in the previous program. Now I am asking you to get me the size of int star only. Will it remain same or will it change? If it is going to be changed, why? Okay, and write a C program for these two programs, okay, using pointers where you are supposed to read the data from the user. Okay, now these are the reference book, pointers in C by Yashwant Kanetikar, and one more pointers on C by Kenneth 3. And there is one fantastic book by Yashwant Kanetikar, Interview Questions in C Programming, first edition, for preparing the interview. From these particular reference book, I mainly drawn these PPTs. And the next is only practice, practice, and practice. Okay. So if you have any doubts, you can always contact us. All these sessions anyways, which is there in your YouTube, even after this session you can go back through the session and check it. If you have any doubts, go back once again, you look back to the video and try to understand the concept. I hope I have given the little bit of glimpse with respect to fundamentals of the pointers. If you have any doubts, let me know, or else take a 2 minutes of break. Exactly 2 minutes. We'll have a next session by Navdin sir.
Hello, sir.
Yes,
Kotre,
sir.
sir. Sir,
Yes, sir.
there should be a poll questions. Poll 2.
Sir, it's there in. Okay.
Okay, shall I post it, sir?
Yes, sir. Yes, sir. You can post it.
Yes. Okay.
I think link is with you. You can post it.
Is it visible, sir? Is it visible? Kotre, sir, is it visible?
Yes. 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 Yes.
Yes, students, go take the poll question number 2. This is a link. The same will be posted to your YouTube. in a minute, and again I'll just put it. The poll link is also provided in your WhatsApp group. Please give the poll question. Answer the poll question quickly. 2 minutes for you.
It is there in your live chat. https tiny.cc./ questions 2. So quickly.
Students, once you are done with your poll question, please wait for a while. We'll be starting up with session number 2 by Dr. S.S. Navalgund sir. The session will continue for next half an hour. The session will continue for next half an hour. Please wait for it. Yes, sir. Sir.
The I made you a collaborator for the quiz.
Okay, sir. Okay.
If you have access to Gmail there,
Okay. Okay.
you can stop it because
I'll just
in
go
my
through
PC
it.
it is.
Uh, no, sir. You have not made me collaborator. It's okay. We can start with the next process from talk by Navalgund sir.
Okay,
We can verify the
we'll
answers.
right now stop here, and later on at the after the Nalgun sir session, we'll show you the answers. Thank you, guys. Thank you very much.
So in another 2 minutes, we are starting up with the next session by Dr. S.S. Navalgund sir. So he'll be covering pointers arithmetic in the session 2, and session 2 will last for next half an hour. The next 30 minutes, session 2 will be there. And if you have any questions, it will be addressed in another 5 minutes. Uh, if not at 12:30, we'll be ending the session by max 12:40. If you have any queries regarding the first session, you're free to post it. And you can have some water in between. join afresh for the session 2. And we are overwhelmed with the responses and the interaction by the students in this session. A lot of students were very actively participating in the interaction. We expect the same in the subsequent sessions too. So you can post your queries till then. Another few minutes, we are starting up with the session 2. And you can have these recorded lectures are available even after this session also. Uh, you can subscribe the channel for the further updates and to view the video recorded of the current sessions later also. You can view it later also. Sir, are we ready for the next session? Start, sir. Well, sir, are we ready to start the session number 2?
Yes, yes, Shriman.
Yes, sir. Students, we are ready for the session number 2 by Professor Dr. S.S. Navalgun. This session covers the topic related to pointer arithmetic. Sir, over to you, sir. You can share your screen.
Okay. Okay, thank you, Sri. Can you see the screen now?
Um, yes, sir. Yes, sir. It's visible.
Okay, good morning to one and all. Nice to get to connect with you. So, in the last session, Professor Koteshwali has taken us through the basics of pointers in C language. We just had a look at what is meant by a pointer, the value pointed to by the pointer variable, and different syntactical aspects of how to use pointers. In this particular discussion, we are going to go through the basics of pointer arithmetic. That means, is it okay if I increment or decrement the value of a pointer or pointer variable, so on and so forth. Now, this is the entire agenda for this entire uh, course. Out of this, I want to start off with uh, some important aspects of the meaning of different parts of program. Now, on the right hand side of your screen, you can just view the contents of the random access memory or RAM. So this is just a partial picture because we know that a part of RAM is consumed by the OS image and some other part is available for the user's data or user's area. Now, the moment we start talking about the different parts of program, the entire memory is split like this. A part of memory is meant for storing the code, the program that we write. Certain other part of memory is meant for storing the global variables or constants. Then we also have the data stack and data heap. Now here we have some free space which is meant for the purpose of letting data stack and data heap grow. Now it's very important for you to understand that when I look at data, um, there is separate set of locations in memory used for storing them. For example, if I look at local data variables, they will be stored on the data stack. When I have global variables, a separate memory is meant for storing them. Now, data heap is a place from where you are going to make use of the dynamic memory for allocation and deallocation purposes. So we must be able to understand these aspects very well. So can somebody tell me if I say something like int star ptr inside of my main function? So where will that allocation of memory happen? For which part of this diagram the allocation will happen? Your comments in the chat box right away. We say int star ptr. We just declare it. So can you tell me in which part of memory the space will be provided for this particular declaration? Comments? Yes. Is it going to be here global variables, or is it going to be in data heap or data stack? Okay, I repeat the question once again. I'm trying to say int star ptr, and this declaration I do it inside of main function. Inside of main function, int star ptr. Okay, Rakshita says global, Nikhil global variable. Srinidhi says data stack. Rachita says heap. Well, we have a different set of answers here, but please note the moment I declare a data variable inside of main function, is it not a local variable? So if it is a local variable, then the allocation must happen on the data stack part of it. I repeat, data stack part of it. So data heap, as we know, it is meant for dynamic memory allocation and deallocation. We are just talking of declaration of pointer, and that happens definitely inside of data stack, inside of any function. So we have gone through some basics of pin operators as well, the ampersand sign and the star operator. So ampersand sign is called the address of operator, and star symbol is called the data operator or dereferencing operator. So if you want to put some content into some certain location, you just have to be making use of star PTR. That's very important. This is some important thing we have seen. As Professor Kotesh also mentioned, regarding pointer declaration, we have int star myptr. So it just means that I have a pointer variable whose name is myptr and it's of type int. So as it was discussed earlier, the trick that we are going to make use of is to read from RHS to LHS. So we start from this particular semicolon, and when we look at it, we have my PTR, and then it is preceded by a star symbol. It means that my PTR must be a pointer of type int. I repeat, my PTR is a pointer of type int. Now, this point was also highlighted. The moment I say int star my PTR1 followed by star my PTR2. So this means that there are two pointer variables of type integer. Well, let me consider a situation where I don't have this particular star symbol. I repeat, if you don't have the star symbol, if the statement is something like int star my ptr1, comma my ptr2, well, please note my ptr2 will not be a pointer variable because of the absence of star symbol. So this is a very, very important thing you need to understand. Now, we also have gone through the size of a pointer variable. So if I say int star IP, depending on the machine that you are using, certain number of bytes will be allocated for you to store. For example, if I assume that in this diagram, we have a sequence of 8 bytes for the purpose of storing a pointer variable. And then if I look at float star FP, it means FP is a pointer of type float. Its size is also the same. The same thing is true with respect to character pointer as well. Well, I wanted to distinguish between two things, a data type and a pointer to a certain data type. I repeat, a data type and the pointer to a certain data type. Well, what does that mean? It means this. If I say int I, a simple data variable, its size is well, it depends, right? It depends on the machine. So if I assume that the size of integer I is a 32-bit number, it's a 32-bit number. If I also assume that the size of int star IP is, let's say, as shown here, an 8-byte number, both of them are very, very different. Both these aspects are very different. So by that argument, if I say character star C and character star CP, both of them are very different. The size of character is still 1 byte. The size of character star is 8 bytes on this particular machine. So don't get confused, like how can the size of a character pointer be more than 1 byte? Well, it is. The reasoning is very simple. When I'm talking out of a certain type of pointer variable, it is supposed to hold the address, right? When I say it is supposed to hold the address, it must hold the starting address of a particular data type. Well, that starting address is a number of certain number of bits, isn't it? Hence, the size of different types of pointers is exactly the same. The size of different types of pointers is exactly the same. The size of different data types is varying, it differs, but the size of pointer is same. Now, there can be a question like, okay, what is the size of a pointer variable or a size of a pointer? So, what will be your answer? Answer in the chat box, please. The question is, what is the size of a pointer variable? What is going to be your answer? How many bytes? Is it 2 bytes, 4 bytes, 8 bytes? Oh, well, yes, the answer is correct. Shweta says it is system dependent. Well, it is system dependent. But the moment I'm talking of, let's say, a machine where the address length is 64 bits. Oh, well, some people are saying it's 8 bytes. Well, the answer is, please note, it just depends on the machine. It is system dependent. So if I choose a machine where the size of address is 8 bytes, obviously the size of different types of pointers will also be 8 bytes. It will be also 8 bytes. So please understand one thing. The pointer variable stores the starting address of a data. The pointer variable stores the starting address. It does not store the entire range of addresses of a variable. What does that mean? It means if I'm talking of IP, now let's assume that this is starting address 1001. This is a byte location, right? So this is 1001 location, this is 1002, 1003, it just goes on. So I have 1008 location here. So all these 8 numbers are not stored in IP. It is just the starting address 1001 which is stored. So this is a very important aspect you must understand. Now let's try to understand one important aspect before we actually start with the arithmetic operations on pointers. We have pointers to pointers. What does that mean? I'm talking of a double pointer. A simple example is shown here. If I say int a, int star p, int star star q, well, q is called a double pointer. It's called a double pointer because q is supposed to point to another pointer and not to data. Now, if you look at the value of a here, it is initialized to 10, and then we have pointer p, which is initialized to a. Please note, a is a simple data variable; it's not a pointer variable. And then q is initialized to the address of p. What is p? P is basically a pointer variable. So the point is q points to p, which points to a, which has the value 10 inside of it. So if I use a simple printf statement, I'll be able to print the content of this particular pointer. Well, let us try to have a look at these important aspects with the help of some sample runs. Now I'm going to go over to the dev C++ compiler. Let us try to understand one or two important aspects of how pointers are going to look like. Now, let me just say that we have int I or int a is equal to 10, and then I'm going to have int star j, and then we say j is equal to ampersand a. That means I'm making pointer j point to a, right? So we say the value of a is equal to percentage d, and then that must be followed by star j, isn't it? Well, let me see how this program behaves. I'm just going to compile it and run it. It is now compiled, and the answer is value of a is 10. Nothing great about this example. Let me just try to make a couple of adjustments, modifications, and then see if this program is going to work fine or not. Now, one small change I'm going to make is I just declare int star j. Now, the question that I want to ask you is, well, this is definitely meaningless because I don't have any variable called j. Now, the question that I want to ask you is it okay if I say something like this, star j is equal to, let's say, 10? Please write your answers in the chat box. Is it okay if I simply say int star j is equal to 10, and then I'm trying to print the value of j? Is that okay? Well, let me just check it out. Well, we have got nothing. And there is a warning. The warning is, it says initialization makes pointer from integer without the cast. Well, this is simply meaningless because the point is a pointer variable is supposed to point to a data variable. In the absence of a data variable, this is not okay. So, well, I'm just going to make a simple modification now. I'm just going to say something like this. I just get back to my original program, and we say int a is equal to nothing. I just don't initialize it. I just declare it, and then I say star j is equal to 10. Will this be okay? Well, let's just check it once again. Okay, once again, look at this. Once again, the message is value of a is equal to 0 because I just did a mistake. Why? Because the moment I say int a, this is not an initialized variable, and I try to make sure that j actually had the content as 10, and then j was initialized to address of a. Okay, now let me just try to go for a couple of other modifications. In this case, let's say if it is okay to do something like this, int a, int star j is equal to 10. Let me just check the answer. Well, once again, we have not the desired value of output. Can you just tell me the reason as to why this is happening? Can you just comment in the live chat box? Why is this happening? Okay, do you have any answers in the chat box? Okay, now please understand, do you have any difference between saying something like j is equal to ampersand a, and then let's say star j equal to 10? Let's just check this particular answer. Okay, well, we have one comment. J is a pointer which can't be used to store a value. Well, that's completely correct. Shweta says it. So please note here that these are some of the important aspects that you must know. Now, if you look at this particular program right now, I just declared the value of some integer variable here, and then I have declared an integer pointer. I initialized j to the address of a, and then we have star j is equal to 10. So please note, I did not initialize the value of a. I just initialized the pointer. But this is perfectly okay. It did not give me any error message or warning. It is because of the fact that since j is already pointing to a, now, if I make any modifications to j or a, it is one and the same. And hence, we are getting the output as the value of a is equal to 10. This is very crucial. Now, in the previous case, when we try to simply say something like j is equal to 10, it just meant that I'm trying to manipulate the address of j. That was not okay. And hence, we have this particular mistake. So, it's very important for you to understand the concept of a double pointer. I'm just going to show you with help of a simple diagram so that it can be easily understood. Now, if I have variable a, its value is 10. So the starting address of this variable a is, let's say, 1000. Now this address is chosen by the OS. Now I declared a pointer p, which is made to point to a. So since p points to the starting address of a, the value of p is 1000, isn't it? And then we know that since p is also a variable, although a special variable called a pointer variable, it must also be allocated with some memory, right? So let's assume that the system has chosen an address of 2000 for the purpose of storing p. And when I say int star star q is a double pointer, so this must be made to point to p. So since the address of p is 2000, that gets stored as the value of q. And since q is also a special variable, a pointer variable, it must also have some space in memory where it is allocated with. And let's assume that its address is 3000. So it's very important for you to understand that q is a double pointer, p is a single pointer, and a is just a data variable. Well, if you try to say q is equal to ampersand a, now please try to follow this arrow. Q is equal to ampersand a. it means that I'm trying to assign the address of A to Q. Well, that is not going to work out. That is not going to work out. A double pointer is always supposed to point to a single pointer, which must point to a data variable. This is very important. Then we also have the concept of triple pointer. Look at this. Now I have variable A, which gets pointed to by P. P is the single pointer, which is getting pointed to by Q. And let's say if I have one more variable R, which is a pointer variable, if it is made to point to Q, it's a triple pointer. So obviously, I cannot initialize R to P. I mean, you cannot break this hierarchy. Or I cannot say R is equal to ampersand A, because you cannot just jump over like this. So R has to be pointing to Q, Q has to be pointing to P, and P has to be pointing to the data A. Now, different levels of such indirections are possible. Different levels are possible. So the question should be, or could be, how many such levels of indirection are possible? Well, the answer is theoretically infinity. Theoretically infinity. That means I can have a pointer which points to another pointer, which points to another pointer, and just it goes on. But practically speaking, depending on one's comfort level, you can have a double pointer or triple pointer or a pointer which can point to a triple pointer, so on and so forth. So there is a limit in terms of the practical applications of pointers. It also becomes a little tedious to keep track of which pointer is pointing to which other variable and how the data is getting manipulated. You just make one mistake with one star operator or one ampersand operator, and the entire program can be crashed. So if you start looking at pointer arithmetic, it deals with the addition, subtraction, multiplication, and division processes. Now let me assume that I said something like int star PTR in the first place. So now the question is it possible for me to increment or decrement a pointer variable? Well, as you have already seen in the previous session, it is possible. That means I can say something like PTR plus plus, PTR plus plus. So when I say PTR plus plus, it just means PTR is getting incremented by 1. Now, this one does not mean that I start pointing to the next uh, byte. No. If I assume that PTR is pointing to 1001, for example, PTR plus 1 will not take me to an address 1002. No. Because I know that the size of integer is a prefix number of bytes. For example, 4-byte integer if I assume. If the starting address of integer is 1001, so 1001, 2, 3, and 4. These 4 bytes are meant for storing the integer value. So when I say PTR plus 1, it starts pointing to 1005. That means it starts pointing to the next memory location where the new value is stored. Similarly, I can have PTR minus 1. That means it gets decremented by one location. Not one byte, but one location. And what do you say about PTR star 2? That means I'm trying to multiply PTR by 2 or divide PTR by some constant value. Please note that these are not valid operations. They are illegal operations. Okay, now let me just come back to this particular aspect. I now know that I can add a scalar value or a number to pointer. For example, I can say PTR plus, let's say, 10. If I say so, then PTR will be made to point to the next 10th number stored in memory. Well, we just have to make sure that that is a valid data we want to use. The same thing is true for PTR minus 1. The question would be, okay, if I have two pointers, let's say PTR1 and PTR2 of type both, let's say, integer, is it possible to say something like PTR1 plus PTR2? That means, can I add two pointer variables? That is the question. Please answer in the chat box. The question is it possible to add two pointer variables or two pointers? Can I say PTR1 plus PTR2? Is it possible? Answers? Okay, no. Shweta says no. I'm looking for few more responses. Okay, Rishita says no. Okay, Yukta also says no. Well, that's completely correct. While you can add a scalar number to a pointer variable, you don't want to add two pointers. Well, can you just tell me the reason as to why this is not okay? Why can't I add two pointers? What's wrong if I do something like PTR1 plus PTR2? Well, the answer is very simple. If PTR1 points to a certain data, and if PTR2 also points to certain other data in memory, now if I add both of them, I'm going to get sum. Okay, now that sum will be treated as the address of one more variable, which is highly unpredictable. So you cannot simply add two pointer variables. Now, is it possible for me to say something like PTR2 minus PTR1? Can I subtract them? Answers in the chat box. Can I subtract two pointer variables or two pointers? Tushar is saying no, you cannot subtract two pointers. Any other answer we have? Any other response? The question is, can I do PTR2 minus PTR1? Okay, Nikita says so, Anusha is also saying no. Please note that it is quite possible. This is quite possible. So, what does that mean? I'm just going to go over and then show you the way in which we actually do it. Okay, now let me just try to open a new file here just for the purpose of indicating how this is done. Now, I hope you can see the screen now. Okay, if I do something like PTR2 minus PTR1, please note that this is a perfectly valid syntax. This is perfectly valid syntax. But the only thing is, don't say something like, okay, PTR3 is equal to PTR2 minus PTR1. Now, this is not okay. Well, this is not okay. For the simple reason that when you subtract two pointers, that is going to generate an address. Now, that address should not be assigned to PTR3. Okay, so why is it possible for me to subtract two pointers? Why is this allowed? Please note, I should not say something like this. So what I do is I just remove this part of PTR3. So when I say PTR2 minus PTR1, what actually happens is, if I have made PTR1 point to the starting of a string, and if I made PTR2 point to the ending of a string, then if I subtract both of them, don't you think that we are going to get the answer for the string length? This is very much possible, provided you don't assign this difference to one more pointer variable. That is very, very crucial. Okay, so make sure that you understand this point very, very carefully. Now, last 2 minutes, and then I think we're going to wind up for the day. So, obviously, for the same reason, I cannot actually multiply a pointer variable by a scalar, because if I multiply, for example, if the value of PTR is, let's say, 1001, 1001 times 2 gets me 2002. So what is the meaning of this multiplication operation? Well, do I mean to say that I go to an address 2002 and then manipulate the content? Well, that is not okay, and hence it is invalid. The same thing is true if I say PTR slash 2, 1001 slash 2 gets me the division operation. Once again, that cannot be a valid operation at all. Now, this is regarding the pointer arithmetic on arrays. How do I declare a pointer variable, and how do I make sure that different parts of an array are accessed using some particular appropriate type of pointer? I think we are going to take this up in tomorrow's session when we meet and then continue. But in the meantime, do we have any questions? Do we have any questions so far? Please let me know. Please write your comments, questions in the chat box. Okay, then if there are no questions, then back to Shrikant. Thank you so much. Thank you. Okay.
Nalgun sir, am I audible? So there is a
Just
question. There is a question
okay.
from a student.
Okay.
Subtracting pointers may give to negative numbers also, sir. How to handle it?
Well, that's a good question. When you subtract two pointers, we may have negative numbers as well because of the number arithmetic. The point is, we just have to be very careful not to let this happen. Not to let this happen. That means, you don't want to actually make some sense out of the starting address of a string minus ending address of a string. That doesn't make any sense at all, right? So ending address of a string minus starting address of a string makes sense. So the moment you have subtraction of two pointers, make sure that you do it appropriately. So hence, this kind of situations we should never ever give scope to arise from. Okay.
So any more questions, students? I think we can conclude the today's session. Tomorrow, that is day 2 for exploring pointers in C.
Yeah.
We have both the sessions handled will be handled by Dr. S. S. Navalgun sir from 10:30 a.m. to 12:30 p.m. Same time on YouTube Live. So we'll be posting the link of YouTube Live on your WhatsApp group and in the comment section also. Sir, one more question. Can we take it, sir?
Sure, Shrikant, sure.
Yeah.
Okay.
Will that be? It's a continuation, sir. If it is
Yeah.
visible, can you read it?
Okay, will that be used anywhere in real-time programs? Well, the answer is yes. One very simple application I just told you now. Now, you can always make sure that you find the length of a string using a pointer. Now, there are other ways of finding the length of the string as well. But since we know that pointer arithmetic pointers are very, fast in terms of execution, we would like to go for this kind of approach for finding the length of a string. Yes.
Okay. I hope there are no more doubts from students. I'll before I conclude today's session, I'll show you the poll two questions answers results. I'll be sharing on my screen. Just have a look before you wind it up. So I'm sharing my screen to display the poll two results. Navalgan sir, please acknowledge whether it is visible to you.
Yes, it is visible.
Yeah. Yes. Students, we collected around 70 responses. The question 1, the meaning of star I is same as star into the parenthesis ampersand I. False is the correct answer. 58.6% of the students have rightly answered it. Second question of the poll, which among the following statement is or true with respect to pointer declaration? Int star A. 50% of the students have answered all the above. That's a correct answer. If you have answered the other, it is not wrong, but
Action corrected.
all the above is the right answer. So with this, we are concluding today's session. and we will be happy to receive your queries even after the session. You can view the lecture or the session recorded session in the YouTube after the completion of the session also, and the questions you can post in the WhatsApp group also. Okay, we see you tomorrow. Thank you. I once again thank Dr. S. S. Navalgun sir and Professor Quatresh sir for a wonderful session that we had today. Thank you, sir.
Thank you, sir. Thank you.